Part 2, Week 5, Problem Set, Sigma Group. Going through problems 7 through 12. The first one, talking about 30, 60, 90 triangle. Anytime I'm dealing with that, I'm drawing it. I like to draw things. It makes me understand geometry problems a lot better. They tell us in this problem that the hypotenuse is 18. Well, this is simply a test of whether you understand and know the ratios of a 30, 60, 90 triangle. The hypotenuse is twice the length of the short side, this being the short side because it's opposite the 30-degree angle, and the long leg being rad 3 times your short side, so that gives this to be 9 rad 3. You can do trig if you don't know the ratios, and if you don't have to remember as much because you're just remembering SOHCAHTOA, but then you have to know your trigonometry as well. So it's kind of a pick your poison problem there. And then all we have to do is add these guys up. We have 18 and 9, that's 27, because they want to know the perimeter. So all you have to do there is 27 plus 9 rad 3. Another common problem with this scenario would be then to ask what the area is once you find that. And that would just be the 1/2 the base, which is 9, times the height, which is 9 rad 3. So just keep your eye out for that too, because that problem comes up every once in a while. In the next problem it says, two sides of the triangle measure 5 and 12. Which of the following cannot be the length of the third side? Well, the minimum is the difference. The minimum has to be greater than the difference of the two sides, 12 minus 5. So 7 doesn't work. It has to be bigger than 7 there. And the maximum has to be less than the sum. So less than the sum of 12 and 5, which is 17. So which value is not greater than 7 and less than 17? Well, that is answer choice E of 18. You have to be careful because if 7 or 17 were an option, they would not work either because they have to be greater than 7 and less than 17. So just be careful on that. Didn't come up here, but you have to be ready for it. 9, I'm going to try and draw this diagram for you. I'd like to say I'm getting better at these, but I'm just not. I'm not getting better at dealing with this tablet here. They give us a couple things. They give us that this angle is 130, and they want to know this angle here, B. This is basically, again, using the properties of linear pairs and the fact that these interior angles add up to 180. This, and they also give us this angle up here is 51. This is all that's given to us, and we just have to work our way around finding other angles until we can get ourselves to this angle B here. This angle is 130, so the one with that is linear pair has to be 50, so they add up to 180. And then we have this left triangle here has to add up to 180. Well, we have 90 and 50 already, that's 140, so this angle has to be 40 inside. This angle is 51 at the top of the right triangle, and the bottom one is a right angle, so that's 90, leaving us 39 degrees here in the rest of that triangle. And then we're talking about this whole big part here that encompasses angle B. Not a linear pair, but it's a linear triple, so the sum of all three of those angles has to be 180. So if we take 180 and we subtract 40 and we subtract 39, we'll get angle B. And in fact, when you do that, you get 101 degrees, which is answer choice D. So it's just, if you're not sure where to start, find some place and go from there. And that's kind of what we were doing with that problem. Going on to number 10. We're talking about circles now. It says find the area of the circle whose radius is half of the circle whose circumference is 12 pi. Wow, I've got to really read carefully here. Well, if we look at that, the circumference of the given triangle is 12 pi. And we want to know radius, so we're going to set that equal to 2 pi r. They both have pi's, cancel that out. Divide both sides by 2, we get an r of 6. But our circle has a radius half of that. So when we cut 6 in half, we get 3 as a radius. And we want the area of that triangle. So we're going to do pi times r squared, which is pi times 3 squared, which is 9 pi. Answer choice C. On to 11, another circle problem. Wants to know the center is at 1, 4 and the radius is 3, which of the following points are on the circumference of the circle. Now, we just kind of got to hope in this problem that they're giving us the points that are very clearly, you know, on the outsides, left, right, top, and bottom, because that would make the problem a lot easier. So we start with the center at 1, 4, and then we go out 3 in each direction. 3 to the right, takes us out to 4, 3. We go up 3, taking us to 1, 7. We go 3 to the left, takes us to negative 2, 4. I just realized I can't count over here. That should be 4, 4. And we go down 1 to put us at 1, 1. And if you want, you can sketch the circle to get a better idea of what's going on. But we're basically looking for which one of these has 3 of those 4 points, and that is answer choice B. Anytime I'm dealing with a problem like that, I'm drawing, and it makes it a lot easier. And in 12, they want to know what's the area inside the rectangle, but outside the 2 circles. Let me give it a shot at drawing it. Oh, the circle on the left was so good, and then I did a bad one on the right. Whatever. Okay. The diameter is 2. That's the diameter. So the height of this rectangle is 2. And since the diameter this way is 2 as well, and I have 2 of those, the width of the rectangle is 4. So we got 4 across, and we got 2 up and down. Let's get back to conceptually what's going on here. We're talking about this area in the corners, and these 2 little pieces here. And if you've probably seen this problem before in geometry, if you're looking for the area of that, it's simply the area of the rectangles minus 2 times the area of the circle. 2 times because there's 2 circles. So it's length times width, which is 2 times 4, 8, minus 2 times the area of the circle. And in case you forget, area of the circle is pi r squared with a radius of 1 since the diameter is 2. You gotta be careful on that. So it's 2 times pi r squared, 2 times pi times 1 squared. 1 squared is 1, so that doesn't change anything. It's just 8 minus 2 pi, which is answer D. Hope you guys did well on these problems. If you're having a lot of trouble, send me a message, but try and be specific with it so I can really answer your question. And good luck on this week's assessment.